Our second step in our power regulation process is that of rectification. We have to take this signal that has both positive and negative elements in the voltage signal and make it fully positive. And in doing this, we actually make use of diodes in our circuit. And so a very basic rectifier is something called a half-wave rectifier, where I take a regular rectifying diode, I take a resistor, and then what I do is I measure the output across that resistor. And what happens in this half-wave rectifier is that when the wave is on its positive aspect, this diode will conduct and you will measure a voltage across the resistor. So in this example here, we'll use blue. While this wave is positive, our output is going to still remain positive. But when our wave suddenly dips and becomes negative, this diode no longer conducts and we measure 0 volts across the resistor. So when the wave is negative, we now get 0 volts. When the wave becomes positive again, we get the same positive elements of the wave back. So this design right here is called a half-wave rectifier because you are only getting half of the wave. You are removing the negative elements of the wave, so you don't have to deal with it, but you're basically setting them equal to 0, and so you're losing half of your energy because you don't have the negative side of your wave. And so to deal with this, there's another circuit that is called a full-wave rectifier that actually takes this negative aspect of the wave and flips it up and makes it positive as well. And this is what we saw in the original part of our circuit. A full-wave rectifier is a little more complicated, uses a few more diodes, and so you have a typical bridge circuit with one diode here, leading down to another diode this way. So we've got two diodes on this side. Coming down this way, we will have another diode here, here, here. And then to finish out our bridge, we will put our last diode right there. And this will end up being our full wave rectifier. And so this load resistor that we had over here is now going to be across the center of the bridge. And that's going to be the diode that we're looking at. So now, again, we'll kind of do this in red. When our wave is positive now, through the positive aspect, so when this is positive here, this diode right here will conduct because there's a positive voltage on this side. Current will pass through here, and then when it hits this junction, it cannot proceed this way because that diode is reverse biased, and the current will continue this way through our circuit. So during the positive phase of our design, that is the path that our current takes. Now, let's take a look at what happens when our wave is negative as it flows through this bridge. When our wave is negative, and so we can say negative by saying that this side is positive and this side is negative, the current will come through here, hit this junction, and then it cannot go this way through that diode because it's reverse biased, and we will pass through the diode this way, hit this junction. We cannot go this way until the diode will pass through the resistor, the current will pass through the resistor, through this diode, and back. And so even during this negative part of the wave, we will still get a positive flow through the resistor in the same direction. And so this circuit will help us fully rectify this signal. And so it helps us remove all the negative aspects, but one of the drawbacks is again that we have these gulfs here between the positive and negative aspects of the wave. And so these are rather sharp drops, and the signal actually will approach 0 at this point. And so even though it's mostly positive, this is nowhere near a DC signal. So if we were to try to put this into our electronics, it would look something like this. And if this is sort of the 5 volts our devices need to operate, most electronics are going to cut out at about 4 volts and they're going to brown out. And so you don't want to have your voltage rapidly dropping through your signal. And so our last two phases are going to be to smooth this signal out and to make it flatter and then to regulate the signal after the rectifier.